Hello students, a pleasant greetings to you all. Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Applied Mathematics Education. My name is Akin, your math instructor. Of course, I do content related to the Caribbean examination body, CSEC, SEA and CSEC, CSEC exams. I do content related to help students in preparation for exams on a tri-monthly basis and a yearly basis for the upcoming exams. Of course, do not forget to hit the subscribe button below if you've watched any one of my previous tutorials and it has been to of value to you. Do go ahead and hit the like button. Leave your thoughts and comments in the comment section below. Looking forward to hearing from you. Of course, hopefully my tutorial videos are of great value to you. Now, in our previous upload, we would have looked comprehensively, and in my opinion, I think it was comprehensive enough, about the distributive law in algebra. And of course, as promised, we're going to be going on to using that concept here and expanding it even further. Now, what we're going to be looking at here is the expansion of binomial expressions. I kind of simplify it and call it binomial expansion. And so, before we actually get into the different method, a different perspective in how we can actually look at these types of expressions and simplifications, we have to first define what is a binomial expression. Now, here it says a binomial expression is an expression created by two unlike terms connected by an addition and or a subtraction sign. However, they are inseparable under the multiplication and division rule in algebra. Okay, so yes, you can separate them if you're adding and subtracting, but if you are multiplying or dividing, then the terms become inseparable. Now let's look at some examples of what a binomial expression is. Well, in fact, the prefix bi means two and the nomial refers to expression. So therefore, it has to be two expressions binded together, two unlike expressions binded together. So example would have been, say here, 1x plus 4. Okay, x and 4 are unlike, numerical, algebraically written. Okay, 2a plus b. They're both variables, but they're different variables. Okay, say here 2 minus 3xy, something like that. All right, so what we have is a composite monomial expression tied with a numerical value, and say here 4, it could be any letter really, could be t minus 2v, something like that. Two unlike variables tied together. All right, and there's so much. We looked at a wide variety. Yes, so we use a method known as the foiling method to simplify. And when we talk about simplification of binomial expressions, you're looking at an example that is on screen where you're asked to multiply these two brackets. Now, what we have here is in fact a designed example here: 2x plus 3, 5x minus 8. And bracket, as we already know, implies multiplication. So we are being asked to multiply this bracket here, these two terms in this bracket, with these two terms over here. And I mean, naturally, you might feel like this requires you to just, it's a simple process for some persons. When they look at it, you'll be like, okay, this is very simple. This is in fact just 2 times 5 and 3 times 8. But there's a little bit more to it, because when you're looking at an expression like this, what you're looking at is using individual terms from one bracket to multiply the terms in another bracket. And so that's why we use what is known as the foiling method. So the F here stands for multiplying the first term in one bracket with the first term in the second bracket. Then what we do next is that we do the outer. Okay, so we do first term with the outer term here. Okay, then we do inner term, then we do last terms. So the order in which we do this is we go first with first, then we go first with second. So that's first with first and first with second. So we go here and here. Next we do inner. So we do inner, say here, 3 with 5, and then we go inner with outer, or inner with last. Okay, so if we want to look at this fundamentally, then what we're looking at here is this setup here, 2x multiplied by 5x. Obviously that would have given us 10x squared. We already discussed this in our previous video. That's a power of 1, that's a power of 1. 2 times 5 is 10, and x1 times x1, we add the powers x squared. Then we do 2x times 8, we know number with number, that's minus 16, the x comes back. Then we have inner with inner, so that's 3 times 5 is 15 with the x, and of course 3 multiplied by minus 8 is minus 24. Now once we have done that, we can put them all together then in one straight line. So first term 10x squared minus 16x plus 15x minus 24. Now usually you're going to find that the terms that are alike, as long as they are written in the standard form where it's x plus a, x plus b, as long as it's in that form where the x comes first, you're going to find traditionally that the like terms tend to appear in the middle. So we have 10x squared minus 16x plus 15x minus 24. Of course, minus 16 plus 15 is minus 1. We don't usually write the 1, we just usually write minus x because the 1 is understood. All right, and that is how you really approach a question like this. But this question is just the fundamental aspect of the distribution law of binomial expression. You're going to be seeing this intertwining with the distributive law in other types of questions. Now, this method I find is a little bit for intermediate going towards advanced students where they do it sort of mentally. But then there's also another way to look at it. And so when we use the foiling method, you know, in my country, in my region, we call it the bird beak method because it tends to give off the appearance of a bird beak. Now, in this example here, it doesn't really look like a bird beak, but when we do it here in my country, it tends to always look like, say here, and you'll see like a bird mouth forming because that's how we do it. So you sort of see like a little beak, like it's like a little beak, something like that. So that's why we call it the bird beak method. But everywhere you go, there's going to be a different technique. Universally though, you're going to find a lot of math instructors telling you that this is called the foiling method. All right, so which way do we look at this then? What we can do is use the distributive law perspective by simply using the first to multiply the two terms in the bracket. So you look down here and you'll see where I take the x here, that is the x that is on the outside here, and then you'll see that I multiply it by the term that is over here, that's x plus 4. So you'll see that this is x plus 4 here. Then you'll see that I take the plus 2 here, which is inside here, and then you see once again I multiply it by the bracket on the outer. So that's going to be, say here, and I use that plus 2 here. Okay, so you can write it down like this. I particularly love when it's written down like this, say here. So you see here that I take the x to multiply the x, so that's blue blue. Then I take the x to multiply the 4, that's pink pink. Okay, then I take the 2 to multiply the x, red red. Then we take the 2 to multiply the 4, that's purple purple. And that's how we get that sort of setup down here. So then once we have done that, then we can safely use the principle that we learned in our last video, that is x multiplied by x and x multiplied by 4, 2 multiplied by x and 2 multiplied by 4. So then x times x will give us easily here x squared. X times 4 gives us 4x. Then we have, of course, 2 times x is 2x. Then we have 2 times 4 is in fact 8. And by simplifying this, then you see here that we end up with an answer of x squared plus the terms that are alike are in the middle, so that's 6x plus 8. So the rules are very simple. After distributing, right, then we're going to be combining the like terms, then we are going to write down our answer. All right, so that is pretty much the idea behind the distributive law. Now let's take this a bit further by looking at some examples then. So for the examples that we're going to be looking at then, we're just going to be making up our own examples. And what we have here is, in fact, say you're asked to simplify two x plus 3y, or 2x plus 3. Let's keep it simple first. 2x plus 3 multiplied by, I think this is getting in the way, so let's just come down here a little bit. So let's say that you're asked to simplify 2x plus 3 by 4x minus 2. So of course we know we're going to be taking the first term, which is 2x. We're going to be multiplying it by the bracket over here, which is 4x, take away 2. Then we're going to be using the positive 3 here, so that's plus 3. I'm going to be multiplying it once again by the bracket over here, that's 4x minus 2. So this bracket here, this right bracket, repeats itself, and we split up the multiplication of the terms in the first bracket here. Next then we do the usual. Here with here, here with here, here with here, here with here. Okay. So then what do we end up with here is, in fact, 2 times 4 is 8. X times x is x squared. 2 times 2, 2 multiplied by minus 2 is minus 4. X times 2 is, 2 times 2 is 4 along with the x here. Then we have 3 times 4x is in fact 12x. And 3 times minus 2 here is minus 6. So then we have the terms that are alike in the middle. So that's 8x squared plus 04, have 12, pay what you owe, pardon me, and you're going to still have 8 left, minus 6, right? And that is our simplified answer. This could actually go further by factorizing, say here 2, but for now this is our final answer here. All right, so we can make up our own examples then. Let's make up another one. Let's see then that we're looking at, in fact, 4 minus 2y, open bracket then, say here 3y minus 5. Okay, so I've turned one of the terms around just to show you that the terms that are alike may not necessarily be in the middle. So here what we have then is, in fact, say here 4, this first term, to multiply the bracket to the right, that's 3y minus 5, and we have minus 2y, open bracket here, say 3y minus 5 again. Then of course we're going to be the natural thing here and to distribute. So we're going to be distributing here, distributing here, distributing here, distributing here. We would have done something like this in our previous tutorial video, so definitely check that video out. 4 times 3 is 12, and the y comes back. 4 multiplied by 5 is minus 20. Minus 2 times 3 is minus 6. Y multiplied by y is y squared. And then of course minus multiplied by minus is positive. 2 multiplied by 5 is 10. Y comes back here. And so you'll see then again here that the terms that are alike may not necessarily be in the middle, because now you're seeing here where the terms that are alike are in fact at the end here. So therefore then we have to regroup. So I don't know how you choose to regroup. I traditionally like to write my answers in descending powers, so I always tend to group, say here, starting with the square. So I normally start with the minus 6x squared, then I'll go to the terms next, which is the term without a power here, which is 1. So I normally group the 12y and the 10y next. Then I will write the constant last. All right, that looks more traditional for me. And so therefore then that the answer is minus 6y squared. 2 plus 10 is 12y minus 20. And that there is our simplified expression. Now it's very key to note that once it is that you expand a pair of binomial expansion by multiplication, usually what comes out is an expression known as a quadratic expression. Now I do have a tutorial video explaining what the quadratic expression is, but I'm planning to make a fresh one. So if you want to check out what is all about the quadratic expression, I'll leave a link right here in the description, right at the top of the cards here, and also in the description. You can check that video out to see how beneficial that is for you before the new one comes out. Yeah, so that is called a quadratic expression. And you're going to find here that quadratic expressions come in so many different forms. I'm going to be looking at a wide variety of these quadratic expressions, not limiting my students to one level, even though primarily this video is made for CSEC, CSEC, and SEA students. But of course, you're going to find here that lots of other students can benefit from this type of teaching. All right, let's do another one. Let's make up our own examples then. All right, and I'd love for you guys to make up your own examples as well, so you can keep the practice on. Now, what are we looking at then is, in fact, say here, 3x minus 2y in bracket here multiplied by 4x minus 7y. Okay, and then you'll see here that, as I said before, once you simplify and expand a pair of binomial expressions, you're going to find that majority of the time, not majority, all the time, what comes out, well, majority of the time, provided that there's no powers and you're not doing advanced math, then you're going to find that what comes out traditionally is a quadratic expression. But it's going to look a little different though, right? Because we are so accustomed to a quadratic expression being in the form ax squared plus bx plus c, where c is a constant, a single number. But in this distribution here, you're going to find that our constant may not necessarily be a single number, but it's still a quadratic expression. So here then, what do we have? We have 3x, the first term, that's going to multiply the second bracket over here, which is 4x minus 7y. And then we have the negative 2y, do not forget our sign, negative 2y, open bracket, again multiply the bracket to the right. So we're then going to distribute here. We're going to say 3x multiplied by 4x and 3x multiplied by minus 7y, minus 2y multiplied by 4x and minus 2y multiplied by minus 7y. So let's do that. 3 multiplied by 4 is in fact 12, along with x multiplied by x is x squared. So we've got that traditional square at the front. 3 multiplied by minus 7 is minus 21, along with x times y is xy. Negative 2 multiplied by 4 is negative 8, and of course y times x conventionally becomes xy or yx, but preferably write in alphabetical order, and it does prevent you from the ambiguity of the interpretation. A weak student, a student who is not focused, not knowing exactly the fundamental principles, may think that xy is an unlike term from yx. They are the same, all right, as long as they are bounded by multiplication. Then we have negative 2 times 7, that's positive 14, and y times y is y squared. So finally then, what do we have? We end up with, say here, 12x squared. Notice here that the terms that are alike are exactly in the middle here. Not always, but as you can see, it's in the middle this time. So we have minus 21 minus 8, that's minus 29xy. Hopefully none of my students are subtracting and writing down signs. Remember, 21 negative means you owe, 8 means you owe, so you're still going to owe 29, plus of course 14y squared. So we get a very unusual quadratic type of setup here, because we are not accustomed to having a square at the end of the expression. So how can this actually be considered to be a quadratic? If we perhaps to say here, replace the y with the number 1. Let us just substitute 1 for y here. We'll end up with 12x squared, say here, minus 29xy x times 1, right, plus 14y, well, not y, 1, 14 times 1 squared, 14 times 1 squared. And you'll see here that after simplifying this, 12x squared minus 29x, 1 squared is 1 plus, sorry, 1 squared is 1 times 14 is in fact 14. So we still get a simplified quadratic expression in the standard form. All right, but let's not too worry too much about this. The idea here is just to show you the different types of expansion when it comes to binomial expressions. All right, so hopefully you guys got that. Now we're gonna step it up here, and we're gonna be with you here for another 10 minutes or so, just to make certain that this is not just a fundamental video that helps you with one particular area in algebra, but it's also showing you extensions. You know, this is also for advanced students as well. All right, so it's not limited to just students doing CSEC, but every other student who may be struggling with this particular aspect of math. So this segment is for the advanced students. Then let's look at this. Let's say that you're asked to expand. I'm going to make up a very elaborate example here. So we're going to be asked to expand and simplify the expression below. So let's say that you were given, say, let's try to make it as challenging as possible. All right, let's make it very complicated. Let's say then that you're asked to 2x take away, say here, 5 open bracket 3x minus 2 minus 4 open bracket 5 minus 2x open bracket 3 plus 4x close bracket here. All right, and we have a whole lot of stuff going on, very elaborate expression here. Might you get this on a CSEC exam? Probably not. Might you get this in an advanced college algebra course? It's highly probable. Are you going to need this type of skill when you go to the advanced level? Most definitely. So how do we actually simplify this expression? Well, we start out by obviously doing the distribution law. There's a couple of things here that a student may do incorrectly, so we want to point those out and ensure here that these expressions are simplified to precision. So let's zoom up here. All right, here we go. Next then, what do we have? What do we start? Where do we start? Traditionally, you don't want to make the mistake, students, by subtracting the 5 from the 2x. An advanced student will know that that is not probable, because in algebra, we're not allowed to subtract unlike terms. So if you're planning to do that and then distribute the 3x, that's where you would have made your first mistake, which subsequently would have given you the wrong answer. So the first thing we want to do here is ensure that we distribute the minus 5. And we have already said it in our previous tutorial and also earlier in this video. You cannot distribute over a term that immediately precedes the bracket. So just in the event that you try to do that, you'll know that you're making a mistake. All right, so the 2x comes back down. Then what we have here is to distribute the minus 5 here. So minus 5 gets distributed here and here. So minus 5 times 3x is minus 15x, and minus multiplied by minus gives us a plus. 5 times 2 is 10. Okay, all right, and then now here's where the big mistake happens to a lot of fundamental students. Once they see this, the temptation would be to say here minus 4 times 5 minus 4 times 2x. And is that incorrect? No, it's not. It actually is very correct. So if a student does this, and if that's the way that you prefer, remember that once you do the minus 4 times the 5, which is minus 20, and the minus 4 times the minus 2, that's positive 8x, remember to put it back in a bracket, because you still were multiplying this bracket by the bracket to the right. That's where a lot of the students who take that approach tends to go wrong. They forget to actually distribute, once they have distributed the minus 4 with the first bracket, they completely forget that that entire bracket then has to be distributed with the second bracket, which is why I ill-advise that approach to the question. It's not that the approach is incorrect. I think that, in my opinion, doing it that way is just simply making the problem a little bit more complicated and giving a student a little bit more to think about than what you really have to think about. So then, let's just erase all of this here, right? If you want to experiment with the result, experiment with what I've just shown you, and you'll see that you're going to get the same answer, or you should get the same answer. But then I kind of prefer if you guys simply do just the natural here. Minus 5 times 3x is minus 15x. Minus times minus is positive. 5 times 2 is 10. Then what I prefer that you guys do, as opposed to distributing the minus 4 into the first bracket, I would recommend that you put the minus 4 here and you open a square bracket and then you distribute the binomial expression. So I'd prefer if you say 5 minus 2x here and work out what is in that bracket first. Alright, that's what I would recommend that you do, because in my opinion, I feel like if I can get rid of the binomial expansion first, then I can simply distribute the minus 4 with all the terms of that result. So then, let's continue. We have the 2x written down here, minus the 15x. At this stage, if you want to go ahead and simplify that right away, you can, because it's no longer interfering with any term to the right. So you can go ahead and simplify that if you so desire. I'm going to leave it alone because I want to do one thing at a time. I want to be able to simplify all my terms in one line, distribute all my terms in one line. I don't want to simplify, distribute, group in the same line. It's going to make my problem a little bit more complicated than I really want it to be. So 2x minus 15x plus 10. Be careful now. Do not take away the 4 from the 10 to get 6. You leave the terms alone. And we're going to be working out what is inside this parenthesis. Now, let's imagine, what if it is that the term inside it, what if the blue expressions were the only thing that you got? What would you have done to actually distribute or expand that? Well, you would naturally use what we learned earlier. You take the 5 and you distribute it with the second bracket over here, which is 3 plus 4x. And then, of course, you're going to take the minus 2x, that is, and distribute with the 3 plus 4x again. And then you close here, then you close this big square bracket here. All right? All right, so that is how we're going to be approaching the question then. Let's continue to rewrite. We have 2x take away 15x plus, say here, 10 take away 4, and we're going to be simplifying the inside. So we have 5 times 3, that's 15. 5 times 4x, that is 20x. Minus 2 times 3, that's minus 6x. And minus times plus is going to be minus 2 times 4 is 8. X times x is x squared. If you're at this stage of the video, you should really have strong fundamentals when it comes to simplification of algebra. Do check out the video that we did on the distributive law. It will give you a lot more advantage in staying with me in this problem here. All right. Next, then we have to continue rewriting because we're not done. Say here we have 2x take away 15x plus 10. We're then going to distribute, say here, the minus 4 here and here, here and here. Okay, let's do that a little bit better, a little bit untidy. So let's clean that up. Minus 4 times 15, minus 4 times 20x, minus 4 times minus 6x, minus 4 times minus 8x squared. Now, if you wanted, once again, in any sense, wherever you can simplify to make less expressions, it's better. But I kind of, like I said, if I'm going to be doing simplification, that's the only thing that I want to do. If I'm going to be doing distribution, I want to distribute all that I'm distributing before I do anything else. I don't want to do any cross-reference steps, because when we do that, of course, like I said, for fundamental students, it might pose a little bit of a challenge. So then, what we have now is, in fact, we have, say here, 2x take away 15x plus 10 take away, we're going to distribute minus 4 times 15, that's minus 60, minus 4 times 20, that's minus 80x, minus times minus, that is this minus here, times this minus here, that's minus, that's positive 4 times 6 is 24 x, and we have minus times minus all the way out here, which is positive 4 times 8 is 32x squared. So finally then all the brackets are gone. All right, and if you're at this stage, you might just be understanding, hey, this is how these questions actually work, and you'll recognize that it really isn't difficult. Yes, there's a lot of steps to take, but it's primarily a combination of all the things that you have learned so far then. So time to group. Again, for me personally, I like to group in ascending powers. So I'm going to start off with my x squared here, 32x squared. There's no expression with the x squared to group with, so I'm going to go to my x's then. I'm going to have plus 2x. I'm going to have my minus 15x. Let's look for some more x's. Minus 80x. Oops. Minus 80 as opposed to 8. Minus 80x. Plus 24x. All right. Then I'm going to go to my numbers. Then I have plus 10. Then I have minus 60. All right. So I've checked off everything here. I have the 2x, the 15, and the 80, and the 24. I have the 10 and the minus 60, and I have the 32x squared. So now I end up with 32x squared. I'm going to work out all the x's together. 2 take away 15, that's minus 13. Minus 13 minus 80, that's minus 93. Minus 93 plus 24, that's 73. That's minus 69. So that's minus 69x. Verify that on your calculator, guys. And then 10 take away 60, that's minus 50. And this here becomes my simplified expression. Once again, you'll see that it works out here to be in the standard form of a quadratic: x squared, x, and constant. All right, and that there gives us a advanced end to this particular tutorial video. In the event that you see anything of similar nature, you should be able to use these principles and concepts to make the math expression simplify even faster and better. All right, so until next time, guys, take care. Do not forget to hit the subscribe button below, turn on your post notification bell. Looking forward to hearing from you in the comment section if the video was of any value to you, and of course keep on practicing objectively until you become the most consistent math student in your math class. Continue preparing for exams. Do not forget to join me live on my channel every day of the week between the hours of 5 p.m. to 9 p.m. for various live classes that I have during the days in the week, and also on weekends. Look out for structured topics that students may have. So until then, I'll see you next time in another tutorial video. My name is Akin, your math instructor and your math guru. Follow me on all social media: TikTok, Instagram, Facebook, and also here on YouTube. So until then, take care. Peace out. Bye-bye.